So I noticed when looking at 5.1 that there was some confusion about expected value, and that's to be expected, because it's a complicated idea. Um, so what we want to look at is another example here, because there's a lot of numbers, and we don't use the numbers exactly as they're stated in general. We have to sort of think through what is the scenario, what's going on, and it's not always clear. But on any expected value problem, we assume that we are either making a bet, which could include purchasing a warranty, purchasing insurance, something else, and then we have to look at what the values are associated with the possible outcomes of that experiment. So here's an example. You're feeling super spendy and decide to buy an iPhone Pro for $1,000, $999. You can purchase a 3-year replacement warranty, which includes losing it, breaking it, all sorts of other things, for just only $299. We ignore any other charges that might be a part of this because there's always some other little side fee, it seems like. And you estimate a 30% probability you'll need to use this warranty and get a replacement. So really, the first thing is we buy the phone. That doesn't go into our calculations at all. Ignore the dog in the background lapping up water, please. That doesn't go into our calculation that we spent $999. What we're looking at is we buy this warranty. So I can either lose the warranty and not use the replacement, or I can use the warranty and get a replacement phone. And it's always more complicated than just that, but we simplify it down to this basic setup here. And so we have to look at what are the outcomes. Is either we use the warranty or we don't. And then from that, we have to think about what are our numeric values in this case here. If I don't use the warranty, then clearly I'm losing $299. I'm losing the money that I spent on the warranty. If I do use the warranty, then what we've got is that I get something back. I get the value of the phone minus the $299 that I spent to purchase it. So really, I'm making a $700 profit if I use the warranty. And so the probability I use the warranty is 0.3. The probability I don't use it is 0.7. And when I multiply x times p of x, when I multiply x times p of x, I've got 700 times 0.3 is 210. 299 times 0.7, or negative 299 times 0.7 is negative 209.30. And adding these together gives me a total of 0.70, or 70 cents. And so with this setup, with this scenario here, I come out 70 cents ahead on average. Now, could I lose 2 phones in that time period, or break 2 phones and get to use it during that time period? I could. There's a lot of other factors that go into it, and it's not just as simple as these 2 numbers. So on any expected value problem, I do expect to see the outcomes listed. I expect to see the probabilities listed. How you get this number, you can type this into list 1 and list 2 on the calculator and use your one variable statistics to find the mean for this. But another way of thinking about this that helps illuminate what's going on, because this is sort of a cloudy topic, right? Another way of thinking about it is if there's a 30% chance that you're using the warranty, then that's really a 3 in 10 chance of using the warranty. And so we have to come up with a scenario where we're looking at what does 3 in 10 mean. And so one way we could do this is rewrite this and say that instead of it being you that's feeling super spendy, we'll say that a mom of 9 kids is feeling super spendy and decides to buy an iPhone Pro for $999 for her and her kids. I should say for each of her and her kids. So we have 10 phones at $999 is $9,990 in phones for her and her kids. Poor mom. And she buys 10 warranties at $299. Each, which is $2,990 each. Georgia came in and just said hello. So, out of those 10 phones, we're going to say that 30% of the 10 break, giving 3 phones that break. So she gets back 3 new phones. Each one being worth $999. So she gets back $2,997 worth of phones. So she gets that. So she gets $2,997 worth of phones. She spent $2,990 on warranties, which means we have $7 per 10 phones that she's saved. In other words, $0.70 per phone. And that's our average long-term outcome. So E, the expected value, is about $0.7 or 70 cents per phone. Over here, the expected value is 70 cents per phone, but it's hidden in the fact that over here, I'm just looking at a probability distribution. So if it helps to set it up as a story involving being out of some number, purchasing 10,000 lottery tickets or purchasing 10 phones or purchasing 5 dishwashers, whatever it might be, that story can help illuminate what the answer should be. This is not a probability distribution, though. The way I've set this up, this is not a probability distribution. But this is my expected value. Now, this poor mom with 9 kids who happens to have, the price of a, decent used car to spend on phones is probably going to have more than 3 phones break. If you got 9 kids, there's probably a lot of shenanigans going on, and you're probably looking at more than $2,997 worth of phones coming back or getting repaired or whatever it might be. So, would it be worthwhile? Well, if you can afford to buy these, then probably go ahead and buy the warranty, because in this case, you're not losing money. You're actually getting a little bit extra back. And Apple's happy because they're not actually having to spend that $2,997. It doesn't cost them that much to make the phone. So everybody winds up a little bit ahead with this setup.